So a certificate of deposit is a savings instrument that many banks offer. It usually gives a higher interest rate than a basic savings account, but you can't access your investment for a specified length of time. So now suppose that we deposit $3,000 into a CD paying 6% interest compounded monthly, and we want to know how much we'll have in the account after 20 years. So first thing we need to do is identify our principal, or in other words, our starting amount in our account. Now, first off, notice that we are depositing $3,000. We're doing that exactly once, which is why we're talking about compound interest here. So my initial investment was $3,000. Let's see here, what's my interest rate? My interest rate is 6%. And of course, that's an annual rate. Interest rates are typically given as annual rates unless it's specified otherwise. How many compounds am I going to do in a year? So we're compounding monthly. Monthly means there's 12 compounds in a year. And finally, we need to know how many years we're investing our money for. And so we're told 20 years is what we're looking at. And so there we go. So you might remember the formula for compound interest looks like this. And so let's go ahead and plug in what we know. So we know that we're looking for the amount after 20 years. The initial amount is 3,000. My interest rate is 6%, 12 compounds in a year. 12 times 20, because we're doing this for 20 years. Now, when I go to evaluate this on my calculator, I'm probably going to simplify a couple things first. Oftentimes, I'll go ahead and divide the 0.06 by 12, and come up with a value there. But I'm actually going to show you a way to avoid that, so I'm not going to do that yet. But I am going to go ahead and multiply 12 times 20 to get 240, because that's definitely going to make my life easier. So here's my calculator. And so in evaluating this, I'm going to start by evaluating the stuff inside the parentheses. And I know I should start with division, so I'm going to take 0.06, divide it by 12, and that's going to give me the monthly interest. So I'm earning 0.5% each month. Now I need to add the 1. And so everything inside the parentheses here is 1.005. Now I need to raise that to the 240th power, so we'll come to our power of button and say, give me the power of 240. And so this entire expression here evaluates to 3.31, roughly. Now, I could write that down, round it off, and multiply it by 3,000, but if I can avoid rounding, I want to. And so I'm just going to go ahead and leave that in my calculator, and now multiply by 3,000 to come up with my balance after those 20 years. And so I'm expecting to have about $9,930.61 in my account after 20 years. Now, you might be wondering, what is that compounding really doing for us? And we can see it really clearly if we compare compounded interest to simple interest. Again, simple interest is what we get when we only earn interest on the initial amount. So if we were earning simple interest here, we would be earning 0.5%, or in other words, $15 each month on our account. If we calculate that out, then you can see that after 30, 35 years, even 20 years, that simple interest, which is growing linearly, compared to our compound interest, which is growing exponentially, diverges quite a bit, particularly as our time goes on. By the time we're out here at 35 years, you know, we've made our balances more than twice as large due to compound interest compared to if we were only earning simple interest.